Alright guys, welcome back. In this video, what we're going to do is swap out our perfect squares, our square boxes, with rectangular shapes, which means in order to make this basically calculate properly in regards to collisions with our ball, we need to change the way we're storing our corners. As a matter of fact, I went ahead and threw a whiteboard into the mix this time around. If you recall, in the last video, what we were describing was you've got a perfect box, and with that, we could say there is a circle. It's going to be a very happy circle, guys. There we go. But since we know that this guy is a perfect square, we were able to come in here and say, let's start out by offsetting 45 degrees. And then each time around, we could basically just add 90 degrees to it. And what would happen is we would perfectly cut right through each of our corners. And then we could, of course, Logan had it set up as 0, 1, 2, and 3, so then we were able to say, all right, if it was within this area, if it was within this area, if it was in this area, and as you guys recall, we had an else which picked up our last area. But this time around, we're going to have a rectangular shape in here, and this is a little bit different. Because of having the rectangular shape in there, we can't just say, all right, there's this perfect circle that's around this, let's go ahead and go 45 degrees, slice, and then continue chopping it by 90 degrees each time, like we did with a perfect square. Can't do that. So to do this, what we're going to do is we need to come in here and basically get an XY position for each of our corners of our rectangular shape. Now let me go ahead and see if I can get a halfway decent line drawn here. And once again, this guy is going to serve as 0 right here. So what we need to do is, well, with this location over here and 0 right here, ta-da, we can calculate our angle, and we can then basically calculate this angle. And again, beautiful lines, I know. That angle, and finally this angle down here. Hey, no laughing, Logan. All right, and then with all of our angles now, of course, once again, we know that we can simply say, are we in this area? Hey, it's the top. Are we in this area? Good, it's the right side. Are we in this area? It's the bottom. Otherwise, we're over here.
Right, but now the ranges between those angles will match the length of the sides that they go
Right.
with. Because if we use the square applied to this, we would have a case where the sum of the top would be counted as the left or right.
Exactly. So with that being the case, that is what we're going to do. So it's really just a bit of changing up. We're going to be working inside the box class, and then we're going to go back over to the game class and make sure that our grid is populated with a bunch of rectangular shapes as opposed to square shapes. So Logan, let's go ahead and jump back over into Visual Studio Express.
All right, back to Visual Studio. Let's jump over to the box class, and let's put together a new way of coming up with the corner markers. I'm going to jump just above the where we define the corner markers field, or initialize the corner markers field, and I'm going to make a new array, this time a vector2 array of corners.
Okay.
We'll say these are the actual positions of the corners for this box.
Basically the little black circles I drew just a second ago at each corner.
Exactly. So I'll make a vector2 array, jump back a little bit, and we'll call this corners, and we'll set that equal to a new vector2 array of 4 elements. And then we'll simply set those elements to whatever the corners themselves should be. So that would mean corners sub 0 will be equal to a new vector2 of the box's position. Now remember though, the position in this case is centered on the object, so we actually have to jump up and left in this case to get the top left corner. And we can use the origin to figure out how much we have to move in order to get to the top left corner. So that would be this dot position dot x minus this dot origin dot x, and that would give us the top left for x. Then we do the same for y. So this dot position dot x
Dot y?
This is still dot y. Okay, I was
it's all
off
good.
in La La Land. All right, this dot position dot y minus this dot origin dot y. So that will make up the first corner. Again, just taking the position, and we're subtracting in both cases. So we go from the position. In this case, we go left for the origin, so then we hit the left side of the box. Then we go up for the origin, then we hit the top side of the box. So that would be the top left point.
Very cool.
And you'll notice that as we go around and establish these corners, we establish them in the same direction as we had, so that we can still check markers 0 to 1, 1 to 2, and 2 to 3 in that order. So for the rest of the lines, let me copy this corners line and change this to corners sub 1. where we'll look at position. Now this is going to be the point 1. This point is going to be on the right side of the box, the top right actually. So we need to go from the position to the right side of the box. We'll do plus origin.
And we'll continue going up for Y.
Right, we'll continue going up, so we'll leave Y minus origin. We'll copy that line again, and this will make corners sub 2. This time, we still need to stay on the right side of the box, since this is going to be the bottom right point. So we'll leave X plus origin, and we'll change Y to plus Y origin. Right. That way we'll hit the bottom right of the box. Then one more corner to make the bottom left, so corner sub 3. This time we need to be on the left side, so we'll subtract the origin from X. And we need to be on the bottom still, so we'll leave the Y being positive origin, or plus origin.
Right.
Alright, now that we have these corners, we need to run the necessary calculation, the same as we had done for finding the angle of the ball. We need to run that inside of the for loop. Also, I can take away the where we'd set sub-0 of corner markers by itself. We can wipe that out entirely.
Because we're no longer counting on this being a perfect circle that we're working with.
Right. And what I'll do is I'll jump over to ball and grab the exact same code we had here, the direction and the angle calculation. Drop that into the for loop, so we'll completely erase where we were setting corner markers and replace that with the angle calculation. Only this time, instead of storing a float angle, we simply change this to the appropriate corner marker. That would be this dot corner markers sub I. And let me just look over this and make sure that this is, because we don't have this minus box since we are the box.
That's right.
Instead, what we're looking at here is the corners to the center of the box. So really, this dot position is replaced with the current corner that we're looking at. And this is actually where we use that point, corners sub I. So this is why we define this array. It's because it's the points to check here with this vector against the box's center, and then use the resulting angle set up here.
Okay.
So minus, also box, if we try to build now, this would actually be an error because box doesn't exist as a field. We're looking at ourselves as a box, so that would be this.
Right. All right. So that was pretty easy.
So, I mean, yeah, really just a matter of setting up the corners. Now I guess we could go back to the game and change all of our boxes to be rectangles.
Sounds good.
So if we go back to the game class, let me change up the way the grid is going to be laid out. I'll change the rows to...
we'll do 5 and 8. So I have 5 columns, 8 rows.
All right, 5 columns.
I used typed 8.
Whoops, 5 columns and 8 rows.
Perfect.
There we go. And now the boxes size, let's do boxes that are 60 by 20. And for spacing these, since I want to make these, I now want to make sure that the center column is actually centered on the screen for later when we mess with the actual balls bouncing some more, is I want to set up a column width variable so that I can accurately determine where the center of the screen should be.
Right.
So I'll make an int for column width, and we'll set that equal to screen width divided by the number of columns. So that we can turn around and use that as we're positioning the individual boxes. We can say x times the column width now. And then we can offset by half of the column width. So column width divided by 2. And then for x, or excuse me, for y, we'll space these by maybe 60 pixels instead, and then offset from the top by 10.
Once again, magic numbers, but the whole idea, proof of concept, just showing you guys this does indeed work.
All right, so let's see what this is actually looking like now. If we build and run,
Ooh.
Now we have a lot of rectangular boxes.
And let's take just a moment and let's watch real carefully as to what's happening with our bouncing.
Make sure that, and it looks like it's respecting all of the corners properly.
It does.
It almost looks like it's stuck in a loop based on that velocity.
Yes, let's go ahead and change the velocity up just a tad.
If we change maybe this up to 3.
All right, let's see.
So hit another nice loop, but still.
Oh, there it goes. It just switched.
So, and then we still hit a little bit of the sides, but it does look like it's working. We're hitting very close to some of the corners.
Yeah.
And then missing the appropriate ones. We're hitting the appropriate ones and bouncing in the right direction.
Yeah, you're bouncing all over now. Very cool. Excellent stuff.
So that's working very well now.
I think that's pretty much everything. In fact, I know it is, that we set out to accomplish in this video. So more or less, we took our squares out. We put rectangular capabilities in. Actually, we can still have squares in there because now it's dynamic.
If we threw the corners at the corners of a square. There's no reason that wouldn't work.
Sure,
It's
exactly.
just able to handle rectangles now.
All right, and so with that, that is going to wrap up this video. Thanks a lot.